Today we'll explore the essential concepts that form the foundation of computer programming. Let's begin with understanding what is problem solving and what it means in this context. Computers are incredible tools, but can't solve problems on their own. They rely on us humans to provide them clear instructions so that they can perform those instructions and get the desired result we want. This process of problem solving involves several key steps. 1. Identifying the problem. Devising a solution or algorithm for implementing it through programming. Steps in problem solving. Analyzing the problem. The first step is to fully understand the problem. This involves identifying what the inputs are and what outputs are expected from our program. Without a clear understanding, our solution might miss the mark or the result we need. Today, let's discuss about the problem we are going to be solving. We need a program that multiplies two real numbers and prints the result. So what are the inputs? Two real numbers. That could be 3 and 5 or 2 and 1, etc., whichever you want to put. The output, the product of two numbers. So let's talk about, for example, 2 and 5. If we multiply 2 and 5, the output will be 10. Second, developing an algorithm. An algorithm is a step-by-step procedure to solve a problem. Think of it as a recipe. There are multiple ways of achieving the same result, but we need to choose one which is the most effective and efficient one. Step 1. Input the first real number. Number 1. Step 2. Input the second real number. Number 2. Step 3. Compute the product. Result equals to number 1 times number 2. Output or print the result. Print result. Step 3. Once we have our algorithm, we can translate that into programming languages like Python. This involves writing clear and structured code that the computer can understand and execute. Step 1. Input the first number. num1 equals to float, and in round bracket input, and then inside that another round bracket. Inside that we put double quotes and write enter the first number and then close it. Step 2. Input the second number. num2 equals to float, and then round bracket input, and then inside that another round bracket and then double quotes and then write enter the second number and then close it. Step 3. Compute the product. Result, let's assign a variable which is result, and that is equal to what is the value of number 1 times the value of number 2. Now output the result. Print inside round bracket double quotation, we add the product of num1 and num2 is, and then we print the variable which is the result, which will show the value of two numbers, thus multiplication of two numbers. Step 4. Testing and debugging. Testing is crucial to ensure that our program works correctly. We can check for syntax errors like typos, incorrect symbols, or logical errors where the program runs but it doesn't produce the expected output. Debugging involves finding and fixing these errors. Understanding algorithms. An algorithm is like a roadmap for solving a problem. For example, imagine we need to find the square of a number. So to achieve that, we first input a number, that'd be any number. Then second step, compute the square of the number. And step 3, output the result. Algorithms ensure that our solutions are precise, unique to the problem, and produce the desired result efficiently. Representation of algorithms. Algorithms can be represented in two ways. Flowchart, a visual diagrams that show the flow of a solution using shapes, arrows to represent the steps and decisions. And the second method, pseudocode, is language which is used to outline our algorithm using simple human readable instructions. It helps us to plan before diving into the specific programming syntax. Why algorithms matter? Algorithms are the backbone of programming. They enable us to translate human ideas into instructions that the computer can follow reliably. By designing good algorithms, we ensure that our programs are accurate, efficient, and meet the needs of the user. Characteristics of good algorithms. A good algorithm are precise, each step is clearly defined, unique, each step's outcome only depends on the previous steps and the inputs, finite, they have a clear endpoint. Input and output clearly defines what data the algorithm will accept or reject and what it will produce as the result. Today we laid the groundwork for problem solving and programming. Understanding these concepts will set the stage for learning Python effectively. Remember, problem solving is just not about coding, it's about breaking the problem into simple steps that we can solve it efficiently and effectively. So thank you so much for watching. More videos will come out soon, and if you have any doubts or questions, please comment down below and subscribe.